like indexing. So there the name says indexed addressing mode. Indexing, where you have heard the term indexing, you have seen array index. Okay, so array denote ಮಾಡುವಾಗ programming language ಅಲ್ಲಿ, if I give a of 10, okay, int a of 10 anta kotre, a of 0, all those are different memory locations. A of 0, some value stored here. A of 1, different value stored. A of 2, a different value stored. Okay, suppose I assume that this is 16-bit addressing mode. Okay, 16-bit machine means e memory alli there are each word is of 2 bytes. Andre suppose the first base address of this array, the first address of this array is suppose 500. Second index, that is a of 1, will be of 502, multiples of 2, 504, the third, and then it is 506, and so on. There is a jump in the to get the specific array value. Okay, I want to move at a distance. Okay, with the base value, I want to add some value to get the, suppose a of 9, right? The 10th value I want to get the 10th value. Okay, when I want to get the 10th value, I add, okay, 10 into 2. Okay, so 500 plus 20, I go to the 5, I get the effective address as 520. So at 520, I will get a of 9. Okay, I'd go to, that is, I displace, I move to a specific offset. Okay, when you want to move to a specific offset from the base value, you use indexed addressing mode. Okay, so to jump to different locations, and I know at which location I should move to, in such cases, indexed addressing mode is used. Fine. Okay, so index addressing, the effective address of the operand is generated by adding constant value with the register. It is represented as x and ri. X is the constant and ri is the CPU register. Okay, now how it is denoted, you can just give, I'm using move. Okay, means I want to copy the value at a specific location to a register. Okay, I will use move 10 of some address, okay, comma R3. Okay, suppose in R1 register, some location is present. Okay, R1 register 500 is present. So 500 plus 10 is the effective address. 500 plus 10 in memory location, go to the memory location 510 and retrieve the operand, the value. Okay, and this value is moved to, as per this instruction, it is moved to R3 register. Okay, this is indexed addressing mode. Fine, this is indexed addressing mode. Now there are two varieties, two difference in indexed addressing mode. We'll see that what is this difference. Okay, offset means what? This displacement, base address in the h2 displacement, by how much it is moved, by how much by how much moment the operand I can retrieve. Okay, so this is the offset, or it is called as displacement. Okay, displacement. So there are two ways. The offset is mentioned as a constant. Okay, means I get 20 and R1. Offset, that is displacement, is mentioned as constant. X is the constant and Ri is the register. Okay, so Yes, RI is the register. The register RI is also called as index register. It is one of the general purpose registers which is present in processor. So processor will have the base address. Okay, so the two types are offset is used as offset is present as constant, or offset is present in the register R1. Okay, in register R1 offset will be present and base address will be present in the constant as per the programmer assembly language program how it is written. So it varies. Sometimes base address might be this, the offset. Okay, so these are the two variations. Offset is given as constant value layer, that is XLE offset value is given, and the other cases offset is given in index register. Okay, so offset, that is 20, is given within this register it is stored. Okay, so that is the types. Now coming to this example, you can see here offset is given as constant. The earlier examples what we had taken, 20 is the constant and R1 is register. R1 only it has the base address. Okay, so R1 base address is added with 20, you get 1020 as the effective address and operand is taken. Okay, offset as a constant. Here offset is present in the index register. So this is the base address, constant XLE base address ide. Okay. However, what is the content of R1? It is some address. So add it with the content is added with the base address and the you retrieve the operand value. Okay, this is as I told, this addressing modes in detail you will be learning in next semester. Okay, for now you should know that there is these are the different types of addressing instruction andre how to retrieve those operands from the instruction. So there are different addressing modes. Okay, now this is an example. Suppose you want to add these numbers. List is an array. Okay, list is an array and you want to add the test values, test 1, test 2, test 3 of one student and the next student values. All those values are stored in this memory location. Okay, this is a RAM memory location. Okay, n students values are present. Okay, n student values are present. This is student 1, student's ID and test values. Second student IDs and test values. All these are variables. Variables values must also be stored in RAM along with the program. Okay, when the execution starts, the values whatever is generated, the variables, all that will be stored. Separate memory locations will be given to those variables also. Okay, in such cases where there is repeated addition which is taking place. Okay, here addition has to do, again here add, again next add, the summation you are finding the added sum of some 3 test values. Okay, in such cases index addressing mode is present, index addressing mode is used. Okay, how the index addressing mode is used, here there is a small program. Okay, there is a small program, you can see this is list or not, immediate addressing, hash list. Okay, list is a constant, it has some value. So list memory locationally it has some value. What is the value? Suppose memory location is 500, so 500 value is stored in list. Okay, so this is a memory location. Fine, so here moving, this is an example, R not only 500 is there, that is moved to list. Okay, means here the location is 500. Okay, now for this 500 I have to add plus 4 plus 8 plus 12 to get these values. Fine, just to understand this. Just an example of how the addressing mode, indexed addressing mode can be used. Fine, I'll explain. Try to understand. Till now, for the exams, it is not asked. You can just observe how it is used. Okay. Now, clear R1, clear R2, clear R3. What it says, you can easily understand. All these are CPU registers R1, R2, R3. The content of it is cleared so that there is no junk values. Okay. Move the content of n to R4. Okay, content of n to R4 means n value. What is n? N is the number of students. Okay, number of students. How many students? The summation I should find. Suppose five students test results I should check. Okay, so 5 was moved to R4 register. Fine. Now the test 1 datas are added. Okay, test 1 datas are added in R0 register. There is the value. Okay, R0 register. That is the value test. The list constant value 500 is present in R0. Okay, means base address is present in R0. So base address plus 4 and R1 is added. Okay, so base address plus 4. I get the first test summation. So base address plus 4 is stored in R1. Suppose the values are the values which is stored for test, it is 10, 20, 30. Okay, here also 10, 20, 30. For simplicity, I am taking. Okay, so 10 is, R1 is cleared initially. The value 10 is added with R1 and the result is stored in R1. Next, test 2 data. Test 2 data is plus 8 is test 2 data, that is 20. 20 is stored in R2 register. Then 30 is stored in R3 register. Okay. Now next I should add the next student data. Test 1 data I should add. Test 2 data I should add with this. Test 3 data I should add. Okay. So I should move to the next student. That's why add to R0 plus 16. Okay. So 16 is added so that you can move to the next student. So to R0, R0 contains 500, correct? I'm adding plus 16 so that R0 will have the value 516 now. Okay, now the base address is considered as 516. From here, plus 4, plus 8, plus 12. I get access to those data, test data. Okay, now there is the loop which is used for adding numbers. Okay, I should add 4 students test data. Test 1 of 4 students should be added to one someone. Okay, test 2 of all 4 students should be added and put in sum 2. Test 3 results of all 3 students, all 4 students must be added and put in sum 3. Okay, so sorry, 5 students. 5 students data, test 1 data should be present in some one memory location. Test 2 data of all students must be put in sum 2 memory location, and test 3. All students though test 3 data should be added and put in sum 4. Okay, now decrement R4. One student data I have already added. Okay, decrement R4. R4 becomes 4. It is decremented by 1. Okay, check if it is 0. Check if R4 is 0. If R4 is not 0, if R4 value is greater than 0, again loop. Go to the initial location. R0 is incremented to plus 16, that is 516 it becomes. Okay, add the content of R1 and 516 plus 4. Okay, 516 plus 4 is this test 1. Fine. So like this, the summation of all students test datas. Test 1 of all students is added and put in R1. Test 2 of all students test 2 is added in R2. And all students test 3 data is put in R3. Okay. To get the next access, next student access, I am adding plus 18 to plus 16 to base address. Okay, because I know that each of the means after 16 addresses, the 16th address have the next student data. Okay, here also list 16, this plus 16, I get the next student data. Okay, so I'm using this program. You can see how the indexed register addressing is used in this program to add the results and how it is used in a loop here. Okay, so just understand this. Branch greater than 0. How does that work is, what must be greater than 0? Whatever the operation was done in the previous step, that operation value should be greater than 0. Okay, wherever branch comes, that means previous instructionally whatever operation was done, after that operation, if the value is greater than 0, okay, then it has to loop. Fine. This is just an example. Okay. Now, indexed addressing, you have seen what is indexed addressing. Okay. This is the symbol of symbolic representation of indexed addressing. Whatever is there in X is added with the content of RI register, and that is the effective address. Okay. Now, here there are different variations, different ways in which indexed addressing can be more used. Okay. Now, suppose if this is the index addressing R1 and R2, two registers are there. One stores the offset and one stores the base address. Okay. So both register contents, one content has the offset value, another register contains the base address. So summation of RI and RJ is done. That gives the effective address. Okay. So suppose RI, R1 some values present, R2. Okay. Suppose R1 contains 1000, R2 contains 50. Okay, 1050. So memory locationally 1050. Whatever value is stored at memory location 1050. Fine. Suppose 10 is moved to R3. R3, okay, 10, the value 10 operand 10 is moved. Okay, so very simple. Indexed addressing mode. If there is an offset, okay, offset, that is address, and then the offset, and then within the bracket, then it is index, or it can be two registers R1, R2, anywhere in the instruction, that then it is index addressing mode, or there can be offset and two registers. Okay, if there is offset and two register values, again add the content of R3, R4 and offset to get the effective address. Okay, so this is index addressing mode. Any doubt? Okay, you have seen an example also how the index addressing mode is used, how the index addressing mode is used in the programs. Fine. So we'll move to the next addressing mode. This is the relative addressing mode. Okay, relative addressing mode is similar to index addressing mode. Means offset ide ಮತ್ತೆ ಒಂದು register ide. Okay, and that addition of its contents gives the effective address. It is similar to index addressing mode, but instead of index register, it is the PC value which will be added. PC andre program counter. Program counter contains the address of next instruction which has to be executed. Okay, so suppose memorially some instruction is there in 500 and okay, another instruction is there in 502. Okay, move anta some instruction is there. So suppose the instruction in 500 PC value is 500 and instruction in 500 is retrieved to the memory. Sorry, it is retrieved from the memory to the processor for execution. As soon as it is retrieved, the next process is decoding. Okay, so when the decoding is taking place, as soon as it is retrieved, PC value is incremented to the next memory location. It contains, the PC contains the address of next instruction to be executed, correct? So PC contains 502. Okay, now suppose in 502, okay, suppose here in this there is a branch instruction, 500, there is a branch instruction. When I decode this, I have read this 500 instruction, it is branch, okay, or jump to a different location. I retrieve this, and when I am decoding this, when I am understanding what this instruction is, already PC is incremented to 502. But here the instruction says jump, that is branch to 1000, location 1000. Okay, when I decode this, I understand that the next instruction to be executed is 1000. It is not 502. Okay, so in such cases, whenever there is a immediate jump required from one instruction to other instruction, then the PC value has to be incremented. Okay, the PC value has to be changed. In such case, the PC content, the PC is considered as a base address. With this, the address, the constant address is added to get the effective address. Okay, effective address is the summation of the offset X plus the content of PC. That will be the effective address. Okay, suppose the instruction is like this, move 20 and then to PC content, okay, to R1 register. Fine. So this is the relative addressing mode. Okay, next is auto-increment addressing mode. Okay, auto-increment and auto-decrement. There are two types. Very simple. So auto-increment means it is similar to register indirect addressing mode. Okay, and the indirect addressing mode through register, like here. Okay, move R1. R1 contains the address, effective address of the operand. Okay, but there is increment, means the operation admele, after this it is post increment. Okay, you can see. So after this operation, R1 value is incremented by itself. Okay, now suppose in this example you can observe R1 is 3300. 3300 memory location. No? So as I have told, it is R1 plus R1 means what? It contains the effective address of the operand. Okay, what is the effective address of the operand? It is 3300. At 3300 there is the operand value. Okay, that has to be moved to R2. Fine, it moves to R2 and also R1 gets incremented. The content of R1 changes. It points to, it increments to 3302. Okay, here we are considering the machine, the 2-bit machine. Okay, 2-byte machine means 16-bit machine it is. Okay, so memory addresses increase by 2, multiples of 2. Okay, 3304, 3306 and so on. Okay, it is multiples of 2. Fine, because it is 2-byte addressing, 2-byte machine which is used. Okay, so hence we are taking this 3300, 3002. Okay, and now it is moved to the R1 values incremented. Okay, it is indirect addressing mode only using the register, but it is a special type. There is auto increment plus auto increment. Ili plus ide. Okay, there is no minus. It is plus. Okay, post increment. After this operation, indirect addressing mode is done, there is the increment of the instruction is the value of R1 register is incremented by 2. Fine. Next is auto decrement. Auto decrement is pre-decrement, post pre-decrement means R1 value ಏನಾದರೂ 3302 ಆಗಿದ್ರೆ, if R1 value is 3302, it decrements first. Okay, the value is decremented first, 00, and then the instruction executes. Okay, so the content whatever is there in 3300, 1F is moved to R2 register. 1F will be, so if this is R1, this is R2, 1F will be moved to R2 register. Okay, so it is pre-decrement. First to decrement agi, because it is first, okay, it is put before the register value. So first decrement the content of R1 and then fetch that data. 1F is fetched. Okay, whereas here it is post decrement. For post increment, auto increment is post increment, means the R1 value whatever is there, the content of this particular memory location is retrieved. So this is R1 and this is R2, suppose. Okay, so move R1 content to R2. R1 is 3300 memory location. The content of the effect, this gives the effective address. Okay, so this is the operand value 6B is moved to R2, and then R2 is incremented. There is post increment. Okay, so R1 value becomes 3302. Okay, R1 value changes to fetch the next data in the program. Fine, here it is pre-decrement. The effective address is given by whatever the register value is there minus the machine code, the machine bit type, that is okay, so it is a 2-byte machine, 2-byte, that is 16-bit machine. Then it is the effective address is decremented by 2. Okay, so if it is 3302 minus 2 gives 3300, and fetch the data what is present in 3300, not data which is present in 3302. Okay, it is pre-increment. Fine. So you have seen the 4 instructions, 4 addressing modes in today's class. Indexed addressing mode. Indexed means it is used in the array access. Okay, effective address of operand is given by adding the offset and the base address, that is the content what is present in register. Okay, so there are 2 types. Offset is given as constant, or offset is given in the register. Okay, there are 2 types. Offset can be here as a constant, or offset can be in the index register. Okay, so those are the 2 types of index addressing. And then okay, there is the types in index addressing. Index addressing, you have seen, it is nothing but, suppose move 20 and in the bracket R1. Okay, this is index addressing. Offset ide. Okay, other than that, if there are two registers within the bracket, so one contains the offset, one contains the base address. Okay, other than that, there can be an offset and base address, and one more constant address. Okay, so summation of this gives the effective address. Okay, so that is index addressing, relative addressing, similar to index addressing, but instead of index register, it is the PC value. It is not register. It is the PC, program counter register. Okay, it is not normal register. So summation of this contents gives the effective address. Next is auto increment addressing mode. Whatever the instruction is there, that instruction is executed as usual. It is a register indirect addressing mode. Okay, but the register value is incremented in auto increment. Okay, coming to the second example here, it is add R3 plus R5. Okay, suppose R3, R5, R4, R5 values are present. I have this is the indirect addressing. So R3 has the address of the operand. Okay, and suppose R4 contains, okay, some value, R5 contains 20. Fine. So in memory location, there is 1000. Okay, I consider as 2-byte addressing only. This is 1002. This is 1004. Fine. The content of R1 register as the effective, R3 register as the effective address. So at this address, whatever value is stored, suppose 10. Okay, whatever value is stored, suppose 10 is stored here. Okay, 10, the content of R3 has the effective address, and its content, that is 10, is added with R5, content of R5, that is 20, and the result is stored in R5. Along with it, R3 is incremented by 1. R3 becomes 1002. Okay, to the next memory, it points to the next memory location. Okay, that is auto increment, auto decrement. It is pre-decrement. First decrement the value of whatever is present in the register by one address. Okay, by one address, and then retrieve the value, operand value from that particular address location. Okay, both these types are register indirect addressing mode, register indirect addressing mode. Okay, means register contains the effective address of the operand. So first pre-decrement the register content. Okay, 1000 idre, it is pre-decremented. So by 2, if I consider 16-bit machine, by 2 means it becomes 9980. Okay, so 9, if this is, okay, R1, R2, R1 contains 1000, pre-decrement. Okay, so at 1000 location, some values present, and there is 998. Okay, by 2, I am decrementing. It is because it is a 16-bit machine. Okay, it is changed to 998, and whatever value is there in 998, suppose 10 is moved to register. Okay, R2. It might be some value here, 20. Okay, but it is moved to R2 register. The value is moved to that value what is present here is moved to R2 register. Okay, we'll see that exercise of which addressing mode is in the next class. No, as of now, any doubt? Any doubt?
No.
Okay, just go through this addressing modes. Okay, use the internet. You can just go through the addressing modes, and in my notes also you can just go through. We will see a questionnaire session in the next class. Okay, and I will give you a quiz also, which consists of this addressing modes quiz and whatever you have learned in first from first. Fine. It is not the end of this module. Okay. There are some more topics, including stacks. Okay. Stacks you will be covering in the data structure syllabus. So you can finish that and then we'll see the stack part. Okay. I will need some 4 classes to do till the stack part. Okay. Stack part we will cover after some topics are covered in data structures. Fine. It is related, hence. Okay. Yes. If there is no doubt, you can exit. Any queries, you can stay back. Any queries, you can stay back. Thank you.